Welcome viewers. Today we are going to conduct an experiment on Orifice meter. The aim of this experiment is to determine the coefficient of discharge in a given orifice meter. Orifice meter is an instrument which is used to determine the discharge through a conduit section. Coefficient of discharge is the ratio of actual discharge by theoretical discharge. In an orifice meter, the theoretical discharge is calculated by knowing the pressure head between the inlet and the orifice. Orifice is a metallic plate which is with a circular hole which is present inside the orifice meter. This is the experimental setup of the orifice meter. Orifice meter has got two different components. One is the inlet and the other one is the orifice. Orifice is a metallic plate with a circular hole inside it. A U-tube manometer is connected between the inlet and the orifice to measure the pressure difference between these two sections when the fluid is flowing through it. The outlet of the orifice meter is connected to a collecting tank to measure the actual discharge through the orifice meter. Conducting the experiment, make sure that the mercury levels in the right and left limb of the U-tube manometer are noted down. Firstly, start the pump and allow the water to flow through the orifice meter. Before taking the U-tube manometer reading, remove the air bubbles inside the U-tube manometer by opening the valves and allowing it for 2 seconds and then close the valves. After a steady flow is attained inside the orifice meter, note down the U-tube manometer readings with respect to left limb and the right limb. Close the outlet of the collecting tank and note down the time taken for a 10 cm raise in the water level inside the collecting tank. For calculation part in the orifice meter experiment, firstly note down the inlet dia of the pipe which is 25 mm. We have to write down in terms of meters. The orifice dia is 12.5 mm. Therefore, the area at the inlet can be calculated using the formula pi d square by 4 which is taken as 4.908 into 10 power minus 4 meter square, and the area at the orifice is taken as 1.227 into 10 power minus 4 meter square. Measure the breadth of the collecting tank and the length of the collecting tank which is taken as 0.3 meters and 0.3 meters. Therefore, the area of the collecting tank will be 0.09 meter square. To calculate the theoretical discharge in a venturi meter, we require the orifice head which is taken as HV. Therefore, the mercury level with respect to left limb and right limb is 80 mm of mercury and 80 mm of mercury. Therefore, the total head will be 160 mm since the left limb is below the negative scale. This reading is in terms of mm of mercury which should be converted in terms of meter of water. Therefore, the formula used to convert the orifice head in terms of meter of water is taken as HV is equal to H into Gm by Gp minus 1, where Gm represents the specific gravity of the manometric liquid and Gp represents the specific gravity of the pipe liquid. The manometric liquid is mercury, where the specific gravity is 13.6, and the pipe liquid is water, where the specific gravity is 1. If we are going to use the H value and the specific gravity of the manometric liquid and pipe liquid, the orifice head in terms of meters of water will be 0.16 meter of water. The theoretical discharge through an orifice meter can be calculated using the formula Q theoretical is equal to A1 into A2 into square root of 2GHV divided by A1 square minus A2 square, where A1 represents the area at the inlet and A2 represents the area at the orifice, and HV is nothing but the orifice head. If we use the area at inlet and area at the orifice and also the orifice head, the Q theoretical value will be 7.96 into 10 power minus 4 meter cube per second. The actual discharge through an orifice meter is given by the formula Q actual is equal to A into R divided by T, where A stands for the area of the collecting tank, which is taken as 0.09 meter square. R is nothing but rise in water in the collecting tank, which will be kept standard, that is 0.1 meter, and also T is time taken for the 0.1 meter rise in the water tank. If we use this value and substitute in the Q actual equation, that is A as 0.09, R as 0.1, and the time taken is 17 seconds, the Q actual will be 5.294 into 10 power minus 4 meter cube per second. Coefficient of discharge through orifice meter is given by the formula CD is equal to Q actual by Q theoretical. For the full discharge condition, the actual discharge is 5.294 into 10 power minus 4 meter cube per second, and the theoretical discharge we obtained is 7.96 into 10 power minus 4 meter cube per second. If we substitute in the value, then the coefficient of discharge will be 0.66. Conduct different trials with respect to varying discharge sections and obtain the CD average value.